Hey everyone, welcome to CBSE Topper series, and in this video the topic that I'm going to discuss is classification of crystalline solids, right? So classification of crystalline solid means the type of different crystalline solids. So let's begin with this particular topic, but before starting let me tell you the type of questions that they can ask from this particular topic are. First type is that they can give you some solid and they can ask you that what kind of crystalline solid it is. Is it molecular solid? Is it ionic solid? Is it covalent solid? Or is it metallic solid? So this kind of question they can ask. So this is the first type of question. Second type of question that they can ask, that what are the, suppose they can ask you what are the properties of ionic solid, what kind of intermolecular forces are present in ionic solid, or give the examples of covalent solids. So this is the second type of questions that they can ask in your CBSE exams, right? So let's start with the topic now. Okay, so as you can see on the screen, I have already taken the screenshot of this whole table that is given in NCERT based on classification of crystalline solids. So we need to understand this table properly, and after that we can consider this particular topic done. Okay, so let's understand this table now. Okay, so guys, if you see this table, so first of all, how many types of crystalline solids we have? So if you see, the first type of crystalline solid that is written over here is molecular solid. I hope you can see it. It is molecular solid, right? Molecular solid is further divided into three categories. One is non-polar, another one is polar, and third one is hydrogen bonded. So we will come to that later. The second type of crystalline solid is ionic solid. The third type of crystalline solid is metallic solid, and the fourth type is covalent solid. So one by one we are going to discuss all of these solids, right? So the first solid that I'm going to discuss with you is not molecular. The first solid that I'm going to discuss with you is ionic solid. What kind of solid? Ionic solid. Now the first question arises that how we are going to identify whether the given solid is ionic solid or not. So suppose if I ask you this question, NaCl solid. Suppose this question is given in the exam, we have NaCl solid, and I'm asking you what kind of solid it is. So first of all, the thought process should be, can you think of cation and anion in NaCl? You are like, yes sir, we can think of Na plus and Cl minus. We can think of Na plus and Cl minus, right? Similarly, if I ask you the second example, magnesium oxide, that is MgO, and if I ask you, can you think of cation and anion? So you're like, yes sir, I can think of Mg2 plus and O minus, Mg2 plus and O minus. Similarly, if I ask you ZnS, that is known as zinc blend, you can think of Zn2 plus and S2 minus. Similarly, CaF2, calcium 2 plus and F minus. So how we are going to identify ionic solid? So simple trick is, when the solid that is given to you, you can think of cation and anion simply. There is one metal and there is one non-metal in that. Then those kind of solids are called, those kind of solids are the examples of ionic solid, right? So if they ask this question whether it is ionic or not, so this is the tip that I have given you. You have to think about cation and anion. If you are able to think about it, cation and anion, cation is metal form and anion is non-metal, then you can say that this particular solid is ionic solid, right? Now first to be understood that how to identify. Now the second type of thing that they ask for particular solid is that what kind of intermolecular forces are present in them. What is the reason for ionic solid, means how ionic solid is forming, basically what are the intermolecular forces, right? So guys, that is also very simple. If I'm saying NaCl, so you are thinking of Na plus and Cl minus, yes or no? Na plus and Cl minus. This is positive charge, this is negative charge. So between this positive and negative there is between this positive and negative there is interaction, yes or no? Between this positive and negative there is interaction. If I ask you what kind of interaction it is, so that is very simple to know. This kind of interaction between charges is called Coulombic interaction, or we also call it electrostatic, or we also call it electrostatic force of attraction. So what is intermolecular force that is responsible for ionic solids is electrostatic force of attraction. Can we say that? The third type of thing that they ask for particular solid is what are the what are the constituents of ionic solid? So what are the constituents? So in ionic solids we have cation and anion. We have different cation and anions. So constituents are ions. Constituents of ionic solids are ions. Understood? So what is ionic solid? Ionic solids are those solid in which electrostatic force of attraction present between oppositely charged ions, and the examples are NaCl, MgO2, MgO2 and CaF2, ZnS, etc. Right guys? So this is about ionic solid. This is about ionic solid. And one more property of ionic solid, I hope that all of you know already, that ionic solid do not conduct electricity in their solid state. When they are in solid form, they do not conduct their electricity. But when you will melt them, when you convert them into their melted form, when you convert them into their melted form, or when you make their aqueous melted form, basically they start conducting electricity, because in solid form they don't have any free ions, but when you convert into melted form, they have their free ions, and because of the presence of free ions, they start conducting electricity. So this question can also be asked, that why they do not conduct electricity in solid state, what in molten form they conduct. So electricity means they have free ions, simple as that. Right guys? Okay, understood. Next type of solid that we are going to discuss is, after ionic, is guys covalent solid. What kind of solid guys? Second type of solid that we are going to discuss, let's say second type we will discuss metallic solid first. What kind of solid? Metallic solid. Now my question to you, what are the examples of metallic solid? Ask this question from you, what are the types of metallic solid? So basically metals, solid form of metals are metallic solids. Like iron, piece of iron is a metallic solid. Similarly, a piece of sodium metal, a piece of potassium metal, these all are metallic solids. So simply metals are known as metallic solids, right? So if someone asks you to give the examples of metallic solids, so you have copper, you have iron, you have silver, you have gold. These examples, as you can see on the board also, these examples you can give as a metallic solid. But the number one question is, what kind of intermolecular forces are present in case of metallic solid? So I told you already for what kind of solid, I told you already for ionic solid, the intermolecular forces are Coulombic forces. Similarly, in case of metallic solid, the intermolecular forces is called metallic bonding. So this particular word may be new to you, this metallic bonding, right? So I will explain to you a little bit about that, what is metallic bonding. So what kind of intermolecular forces are present for metallic solid? It is metallic bonding, right? What kind of metallic bonding? Now what is metallic bonding, guys? So as you can see on the screen, I just want to explain to you the metallic bonding. This is the example of metallic bonding that I'm taking for sodium metal. So what happens in the metal piece? Suppose we have a piece of sodium metal. So what happens? Metals can easily give their electrons. So sodium will give its electrons and it will form Na plus and one electron. So there is not a single atom of sodium. There are infinite number of sodium atoms in a sample of infinite number or very high number of sodium atoms in a sample of sodium, right? So in the sample of that sodium metal, we will have so many Na plus and we will have so many electrons, right? So we have so many electrons, so that is known as sea of electrons. What we call them? Sea of electrons. So many electrons are there, we call them sea of electrons. And when sodium will lose its give one electron and form cation, so we use specific term for that, we call it kernel, right? So we have Na plus and we have C electrons. So Na plus will experience attraction from the sea of electron, and this kind of bonding is called, guys, this kind of bonding is called metallic bonding, right? So this is metallic bonding. Now the next question is that what are the constituent particles? In case of metallic solid? So the constituent particles in case of metallic solids are delocalized. Constituent particles in case of metallic solids are, as you can read from NCERT also, positive ions, that is Na plus in a sea of delocalized electron, right? So many Na plus will be dipped inside the sea of electrons. So what is constituent ions? Positive ions in the sea of delocalized electrons are constituent particles for metallic solid. And yes, metallic solids conduct electricity. Metals are good conductor of electricity, you know that, right? Metallic solids are malleable and ductile. These properties are very simple properties we have already done in lower classes, right? So there is no need to focus on that much. Clear to everyone? So ionic solid, how to identify ionic solid, that is clear. Similarly, metallic solid is clear. What kind of bonding is present for metallic solids? Metallic bonding. What is metallic bonding? Basically, the attraction between positive ion and delocalized sea of electron. This is called metallic bonding, and we also call them constituent particles of metallic solid, right guys? Now the third type of solid that we are going to discuss is, guys, covalent solid. The third type of solid we have is, guys, covalent solid, right? So what is the meaning of covalent solid? So for covalent solid, metallic solids example we can give, ionic solid example we can give, but for the covalent solid I will suggest you, we have handful examples for covalent solids, so you can remember those handful examples of covalent solids. So what are those examples? One is silica, as you can see on the board also, SiO2. One is silica, that is SiO2. We also call it quartz, right? Second one is silicon carbide. This is also covalent molecule. The third one is carbon diamond is also a covalent solid, and the fourth one is, guys, aluminum nitride. So these are the four examples, and I will suggest you to memorize these examples as examples for covalent solids. These are handful examples only, so there is no problem as such to memorizing them, right guys? So these are covalent solids. Now what about covalent solids? So there is another name for covalent solids, that is called, guys, as you can see in the on the board also, that another name is called, guys, network solid. Now why we are calling them network solids? Because, guys, these molecules are giant molecules, okay, and there is a network of covalent bonds, right? These are very giant, big molecules. Basically, the best example is diamond, right? So in diamond, carbon are arranged themselves tetrahedrally, and that will keep on going. So these are giant molecules. And since they are crystalline solids, so they have long range order, so they are keep repeating themselves for throughout the crystal, right guys? So these are giant molecule, network solid. Why we are calling them? Because they are giant, right? And examples I told you, right? Now come to this point, that what are the intermolecular forces? So how diamond is converting into a giant molecule? Through what bonding? It's a covalent bond. Through what bonding? Covalent bond. What is covalent bond? Covalent bond is a sharing of formed due to the mutual sharing of electrons, right? Next is, what are the constituent particles for covalent solid? So the constituent particles for covalent solids are, guys, atoms. Simply, what is the answer? Atoms. Constituent particles are atoms. Understood, guys? So we discussed ionic solid, we discussed metallic solid, and we discussed covalent solid, right? And covalent solid has very high melting point and boiling point. Example is, guys, diamond, one of the hardest substance in the universe, right? Diamond, right? Now the last type of solid that is left for us is, guys, molecular solid, right? Molecular solid. Now everyone pay attention to me. One time they asked this question in JEE mains, what kind of solid P4 is? P4, it was written there, what kind of solid P4 is. So what should be the thought process? Is it ionic? I'm asking you this question. Is it ionic? Your answer is no, sir, it cannot be ionic, because we cannot think of metallic cations and non-metallic anion. We cannot think. So it is not ionic. Is it metallic? Is phosphorus is a metal? No, it is non-metal, right? So it is not metallic solid. It cannot be metallic solid. Is it covalent? Is it the part of your handful examples? No. So what else is there? Molecular. So the answer will be, guys, molecular. Answer will be molecular solid. So if in this way you will think, so these kind of questions will become easy to to solve, right? Otherwise maximum students cannot answer these questions properly, right? Now come to molecular solid. So molecular solid is of three types. First is non-polar. Now what is the meaning of non-polar? So examples, as you can see in NCERT, first example, argon I will consider later. First, let's say CCl4. So if you have CCl4 solid, this is the structure of CCl4. It is tetrahedral, CCl4 solid, in solid form, CCl4 solid. It is tetrahedral. So there is a dipole. For carbon and chlorine bond, we can have a dipole. Dipole direction is from less electronegative to more electronegative. This is dipole, this is dipole, this is dipole, right? So what is going to happen here, that the resultant of these three dipoles, dipole moment is a vector quantity, resultant of these three dipole will be cancelled out by the resultant of this, will be cancelled out by this dipole. It happens, since it is a perfect geometry, it happens, it's a concept of chemical bonding. So its dipole moment is zero. Its dipole moment is zero. So if its dipole moment is zero, guys, so what kind of solid it is? If its dipole moment is zero, what kind of solid it is? It is, guys, non-polar solid. What kind of solid? Non-polar solid. Similarly, guys, dry ice. Carbon dioxide we can convert into solid form, and its solid form is known as dry ice. So dry ice is also an example of what kind of solid? Molecular solid. And in molecular solid, particularly what kind of solid? Non-polar, because carbon dioxide, carbon oxygen, who is more electronegative? Oxygen. Who is more electronegative? Oxygen. Two bonds will cancel out each other, so dipole moment will comes out to be zero. This is for carbon dioxide, right? Similarly for CCl4. Similarly, we have another examples, H2, I2, hydrogen gas convert into solid. I2 is exist in solid only, and argon solid. These are also the examples of non-polar molecular solid, because see, in hydrogen this bond is non-polar only. There is no electronegativity difference. In I2 also this bond is non-polar only. There is no electronegativity difference, right? Similarly, argon also is a non-polar kind of solid, right? So these are the examples of non-polar molecular solid. So you're like, okay sir, we understood, means their dipole moment or the bond dipole moment should be zero for them. These kind of molecules are non-polar. Now the next question that arises, that what kind of interactions are present? That is very, very important. So guys, you might have done this in chemical bonding of class 11th, that in non-polar molecules, the main interaction that are present in non-polar molecules are weak van der Waals forces, and specifically for non-polar molecules, the type of van der Waals force that is present is known as London force. What we call that force, guys? London force, or we also call it dispersion force. So what kind of forces are present? Dispersion force or London force. Right guys, like we have F2, we have Cl2, we have Br2, we have I2. So these are non-polar molecules. So what kind of force of attraction present between these molecules is weak forces, that is London force or dispersion force, right? So in non-polar molecules, the force that is operative is dispersion force or London force. So intermolecular forces, answer is London force, right guys? What are the constituent particles? That obviously that are molecules. So many molecules of H2, okay, combine and give you H2 solid, right? So molecules are constituent particles, right guys? So this is about non-polar. Now come to the next point. Next point, that is polar. Now what is the meaning of polar? Polar example is HCl solid. Polar example is HCl solid. If you write HCl, you can think of delta minus and delta plus. Chlorine is more electronegative, hydrogen is less electronegative. Similarly, there is another molecule of HCl. It is delta plus and delta minus. Agree? Right? So this is one dipole. Why I am calling this dipole? Because dipole has both the end, positive end and negative end. And this is your another dipole. This is your second dipole. One dipole and second dipole. Understood? Now when they will come closer, this is negative and this is positive end. So they will develop a weak interaction. So this interaction is called, guys, what? This interaction is called dipole-dipole interaction. This interaction is known as, guys, dipole-dipole interaction. So this is very, very important, that in case of polar molecular solid, what kind of interactions are present? Dipole-dipole interactions, right guys? Dipole. Similarly, SO2 is same type of example. SO2 is also not non-polar. HCl is not non-polar, right? It has polarities, right? Means its dipole moment is also not zero. Okay, this is SO2 molecule. Okay, so for SO2 molecules also dipole moment is non-zero, because of lone pair dipole in upper direction. Because of this here, it won't cancel out each other. So its dipole moment is not equal to zero, because it's not a perfect geometry. So it is also what kind of solid? Polar molecular solid, HCl solid. Okay, and the last thing that is left for us is hydrogen bonded. So hydrogen bonded molecular solid, the best example is ice. right? So in ice, what kind of intermolecular forces are present? Obviously hydrogen bonding. Because of hydrogen bonding only, ice has open cage like structure, and that result into less density of ice as compared to water, right? So what is constituent intermolecular forces? Hydrogen bonding. What are constituent particles? Obviously molecules, right guys? So this is all about classification. This is all about classification of crystalline solids. So I hope this topic is now clear to you, right? So in this way we can easily find out all our questions. Understood guys? So thank you very much. This is it. So in the next video I'm going to discuss the question based on the video number 1 and video number 2 of solid state. Okay, so do subscribe this channel. Thank you very much.